Hello everyone, what we're going to look at today is the solution to today's LeetCode problem of the day, which is rearranging fruits. The statement of the problem itself is very simple. So what they give us is two baskets represented by arrays representing the fruits inside each basket. So for example here, basket 1 has the fruits 4, 2, 2, 2 and basket 2 has 1, 4, 1, 2. Now our task here today is to make the two baskets identical. That means they have the exact same fruits and the same counts as well. Now, how can we make two baskets equal is by swapping a particular fruit from a particular basket into another basket and taking a fruit from there, right? Now, what is the cost of a swap, right? So suppose I take, let's say, a certain fruit from basket 1 and a certain fruit from basket 2 and I swap them. The cost of a swap is defined as the minimum of the value of those two fruits. Right now, what they've asked us is a very simple question. What is the minimum cost that it takes me to make the two baskets identical? So this problem is actually a pretty hard problem because you have to make a lot of optimal choices here to make the two baskets identical. And if you go for some brute force approach where you're trying all the combinations and trying to find which is the minimum of all the costs, this problem is pretty impossible to solve and it's computationally intractable. Now let's look at how we can make this problem very simple and solve it. Okay, so this is the approach to the problem, and let's start with a very simple sort of question about the problem. Is it even possible that by swapping the fruits in the two baskets that we achieve a state where the two baskets are identical? So, if not, we have to return -1. But let's look at when is it possible so that by swapping the fruits in the baskets that we can achieve an optimal state, and when is it impossible to even make the two baskets identical? Okay, so the idea here is very simple. Suppose let's just see the fruits in the baskets, right? Suppose if any particular fruit has an odd count. So for example, here the fruit 1 occurs once, which is an odd count in the total count, right? And here in the first case, the fruit 3 occurs one time, right? So whenever a particular fruit in the total count in all the baskets occurs an odd number of times, it's impossible that by swapping you can achieve a state where the two baskets are identical, and it's for a very simple reason, right? So we have two baskets, right? And ideally, at the end of all the swaps, like so this basket will have like n amount of a particular fruit, and this basket will also have n amount of that particular fruit, right? So n plus 1 on a total level it becomes 2n, which is an even number. So definitely the count of each particular fruit has to be an even number on the total level to make it swappable, right? Here also we have the same problem where 3 occurs 3 times and 1 occurs 1 time. So again it's impossible to swap. But in the last case you see 1 occurs 2 times and 3 occurs 2 times. So all the fruits in the basket at a total level occur an even number of times, and just by swapping any of these fruits we can achieve an identical state. So this is the first rule we have to implement in our code, that if for any of the fruit the count is odd, then we can directly say that it's impossible to make the two baskets identical. Now let's look at the next strategy. If the two baskets are like have an even number of fruits, then what do we do? Okay, so now we'll go about finding what are the fruits that are misplaced, right? If I just look at these two baskets, very simply, right, I can automatically say like hey, it's pretty simple, there's an extra 2 here, there's an extra 1 here, and just by swapping these two I'll get an identical state, right? But how do we implement this as code, right? For that, first what we're going to do is we are going to have like a total counter which is going to take the count of each of the fruits in both the baskets and tell me how many times each of these fruits occur, right? So let's go for 4. So across the two baskets, how many times 4 occurs? So 1 and 2, right? Perfect. And how many times 2 occurs? 2 occurs 1, 2, 3, 4. And 1 occurs 2 times, right? So we have the total count of these fruits. Now I have to find how many fruits are misplaced, right? So what I'll do for that is just take the count of the fruits in one basket. Now here we do the total counts. Now I'll just take for basket 1, right? So in basket 1, how many times does 4 occur? Here 4 occurs 1 time and 2 occurs 3 times, right? Now when can I say a fruit is misplaced? Okay, so let's take this example, right? 4, 2, 2, 2, right? Ideally, Now, how do I figure out that if 4 is a misplaced fruit or not? Ideally, after swapping all the fruits, basket 1 should have half the count of a particular fruit, and basket 2 should have half the count of that particular same fruit, right? So, ideally, if I have two counts of 4 in my entire total count, right, of fruits, basket 1 should have one count of 4, and basket 2 should have one count of 4, right? So here I know that 4 is not a misplaced fruit, because in the ideal state, my basket 1 should have had one count of 4, right? So this is non-misplaced. But now if you look at these, then 2, right? So 2 occurs 3 times. Whereas in my total count, my ideal count in basket 1, 2 should have occurred how many times? Which is 4 by 2 times, right? So 2 should have only occurred 2 times, but in my basket it's occurring 3 times. So one of these two fruits is misplaced, right? So this is how we figure out if a fruit is misplaced or not. Now let's look at iteratively how to get this result, right? So what we do for that is we iterate over the total counts basket, okay? And we take each of these fruits, right, to so we iterate through the total counts basket. So I for each of the fruits in the total count basket, right? And then what we do is check if, so for a fruit to be the misplaced count, miscount will be how many? So it will be the total, the absolute value of why absolute? Because in some cases I can have for example, in this case I had 3 fruits instead of 2, right? So one of those fruits was misplaced, which is a plus 1. But there could have also been a case where I had just one particular count of this instead of 2, which is minus 1, but still it's a misplaced fruit. So I should still consider the absolute value of the misplaced, right? So that's why I say absolute value of. Now, in an ideal scenario, how much should I have had as a count? Total count by 2. So total by 2 minus the count in this basket, right? So CB1's but corresponding count, right? And this is how you get the misplaced count of a particular fruit. That's it, right? And after this, what we're going to do is just to prove that this works. So first I'll do it for 4. So 4 should have occurred 2 times. 2 times by 2, which is 1. 1 minus count of B1, which is also 1 in this case. So for me, my 4 is not a misplaced fruit. Now let's do it for 2. So 2 occurs 4 times, and here so my ideal count should have been 4 by 2, which should have been 2, and 2 minus 3, which is minus 1, and absolute value of that is 1. So here what it gives me is that 2 has occurred, uh, 2 is misplaced once in these baskets. So what I do is I also create an array which stores all the misplaced fruits, okay? So how do you get all the misplaced fruits? Basically just multiply the misplaced fruit into the number of times it's misplaced. So 2 into 1 I get here as, right? And last, for 1 also let's check. So 1 occurs 2 times in the total count. So ideally it should have occurred how many times in the basket 1? Or 1 by 2. 2 by 2, which is 1. And in my basket 1, it doesn't occur at all. So here we have 0. So 1 minus 0 is 1, and absolute value of the misplaced count is 1, right? And now I have to add all the surplus fruits of 1 into my misplaced fruits list. So how do I do that? So the misplaced fruit into the corresponding miscount, right? So here we had misplaced fruit was 1, and the corresponding misplaced count was 1. So 1 into 1, I get a list of 1 time, and I add that here. So my misplaced fruits here, according to my logic, is 2 and 1, which is exactly what I want, right? Here some people have just looked at this problem and told that the misplaced fruits are 2 and 1. So this is how we get the misplaced fruits. Very simple. We iterate through all the counts. So first we have to take the count of one particular basket, which is count of B1. We already have the total counts calculated. And now we iterate over the total counts basket. And first we find the misplaced count of each particular fruit, right? So that's very simple. Misplaced count is equal to absolute value of, by absolute, because I might have extra surplus or negative surplus, right? So that both cases should be counted still as a misplaced count. So absolute value of total by 2 minus the corresponding count in the basket 1, right? And once you calculate the misplaced count, to make the misplaced fruits list, it's very simple. just that misplaced fruit into its misplaced count. You're just extending the misplaced list. That's it. Now we have found what are the fruits to swap. Now we just have to find a very optimal swapping pattern. Let's go and find out. Okay, now let's talk about what is an optimal swapping strategy here, right? Okay, so let's say we have these two baskets, which is like this basket and this basket, and I found the number of misplaced fruits, right? Now I have to swap the fruits in such a way that gives me the minimum cost, right? For some of you, it may be very apparent, but it's a very simple idea that we just swap these. I mean, we sort the misplaced fruits list. So this becomes 1, 2, 3, 4, 5, 6. And how many swaps do we ideally need? We like to correctly place 6 fruits, right? We just need very simple 3 swaps. It's just half the number of swaps. So and what are the cost of those swaps? Basically, the first half elements, the sum of the first half elements in your list. Why? Very simple. So it's like, for example, I just pick one to swap here. So it's something like I pick one and I swap it with something in the later half, right? So that is like 1 and 4 I swap. Then I can say 2 and 5 I can swap, and 3 and 6 I can swap. This can be in any order, but the idea is very simple. You are just making half the amount of swaps and you're sorting the list. So at each time you're picking, like you're swapping a very less expensive fruit with a very expensive fruit. So at the end, you're ideally greedily picking the lowest cost possible, right? But is this the lowest cost possible in all the swaps, right? This is one great strategy that you can use, which is definitely a valid strategy. But is there a case where this is not very optimal? Okay, let's look at that case. Okay, for example, let's say I have 1, 3, 3, and here I have 1, 5, 5, right? And so the misplaced fruits for me here are just 1, 3, and 1, 5. So if you go by this logic, you will tell that you have to swap once with the cost of 3, right? So you are swapping some 1 fruit, 1, 3 from here for 1, 5, and you're giving me the cost as 3, right? But is this the best cost possible? Definitely not. For example, instead of swapping this a particular 3 with a 5 directly, what if I first take 1, 3 here and swap it with 1, 1 here? So that gives me 1, comma 3, right? So I have incurred a cost of 1, but my baskets are still not balanced. But what I do is I repeat this step again for this one and another 5, right? So this becomes 1 here and this becomes 5. So, and I incur a cost of another 1. So my total cost here is 2, right, in the second strategy, right? Which is much better than my initial strategy of just swapping it directly, right? So this is also something that we have to check. So does this strategy always work, where we just take the minimal cost fruit in the basket and do 2 swaps, like instead of 1 swap? For example, here, right, we're just doing one particular swap, right? We're just taking one less expensive fruit and doing it directly with a very expensive fruit. But here, to do with this like intermediary minimal fruit, we are doing 2 swaps, so it's 2x the cost, right? So now, but is this the ideal strategy, right? Definitely not, because instead of let's say 135, we had 233 and 255. Here, it's just more feasible to directly swap 3 and 5 than instead of using 2 as an intermediary swapping tool, right? So what we have to check when we are swapping for each fruit is which of these strategies is better. Should I just take the minimum, should I just greedily pick the value of that fruit, or should I pick 2 into the minimum of all the fruits in my list? So these are the 2 picking strategies. So one is just pick the fruit's value itself, or pick 2 into the so I'll just write it here, or pick 2 into the minimum of all the fruits in my big basket, right? I'm going to use that minimum element as my intermediary. So I swap an expensive element with the minimum element, and then I swap another expensive element with that minimum element. So that we're going to check for all the cases. So it's very simple, this problem. First, what we do is we check if it's even swappable. Second is we try to find all the misplaced fruits, and third we have this optimal swap strategy where we sort all the misplaced fruits, and then at each instance we check And we do it only for half the time of the misplaced fruits, because in a particular swap you are swapping two fruits in the correct place. So at each instance we check one rule: is it better for me to just swap that particular fruit, or is it better for me to use a intermediary, that minimum value fruit? So this is all the problem is, and we're going to see the code now. So this is the code for the problem. It's very simple. So what we're going to do first is just find the total accounts, right? So how am I going to do that is, first I'm going to find the count of the fruits in the B1 basket. So counter of basket 1. And let's have another variable, B2 is equal to counter of basket 2. And my total will just be total of B1 plus B2. So my total will be another counter with the keys with the fruits inside these baskets, and the counts will be how many times the particular fruit occurs in both the baskets, right? So now we found the count. Now the first step in our rules was to find is it even possible to achieve an identical state of the two baskets, and that was very simple. If any of the fruits has an odd value, that means it's not possible to swap the baskets and put them in an identical state. So that's very simple. If any of v mod by 2 is equal to 1. So if any value in my for v in total dot values, return -1. So if any value in my counters values is an odd number, that means it's not possible to swap, then we just simply return -1, right? So now our first step is completed. Now we have to go to the second step and check if what are the misplaced fruits. And how do we get the misplaced fruits? Very simple. For let's say fruit, comma, the count in total dot items. Right now we're going to find the misplaced count. So before that, let me take a list to actually represent what are the misplaced fruits. So those are my misplaced fruits. So my misplaced count will basically be absolute value of the total. So count by 2. So it's just total of fruit, or just count by 2. I've already extracted this as count. So count by 2 minus, so B1 of that particular fruit. So B1 is my basket 1 count of that particular fruit. You can even use basket 2 count of that particular fruit here. The logic is exactly the same, because we're using the absolute value. It'll all map out at the end, right? So this I've got the misplaced count. Now I have to place those misplaced fruits inside my misplaced list. So misplaced dot extend, right? So that particular fruit into how many times? Into the number of times I have miscounted it, right? So this gives me my misplaced list, like the number of fruits that are misplaced in my entire the fruits that are misplaced in my two baskets. Now what we have to do is we have to swap the list. So sort the list. Misplaced dot sort. Perfect. Now we're very close to the solution of the problem. All we have to do now is to iterate over the misplaced list half the amount of times. By half the amount of times, because in one swap you are probably putting two fruits in the correct places, right? By one swap I mean the whole process, right? Because in one of these optimal strategies we're using an intermediary swap, but even I'm considering that as just one overall swap, right? For I in range len of misplaced by 2, right? So let me also define a cost function here. Cost is equal to 0. So cost plus equal to minimum of just the value of that fruit itself. So misplaced of I, or 2 into the minimum value of the fruits in both the baskets. So how do we get that? Very simple. Minimum val is equal to minimum of total dot keys. So total dot keys would give me all the unique fruits in the two baskets, and I'm just taking the minimum of all the values. So 2 into min val, right? And all I have to do at the end is just return off cost. So this is how we solve the problem. Let's submit it and check it out. I'll also post the Java, C++, and JavaScript answers for you to check it out, and I'll catch you soon with another video.